Okay.
All right, we are at 2 minutes past, so let's get going. So first and foremost, welcome to this Back to the Future call. We have an exciting session set up today. So Doug, if you want to move to the next slide, please. So we are talking about the evolution of URL filtering and DNS security. We're going to focus on why URL filtering had to change from just categorization to do more. And interestingly, how do we stop attacks before they even get started? And this is where kind of DNS security kicks in. So we've got Doug and Cohen that are going to be presenting that to you today. So really looking forward to it. There's going to be a short demo, probably past the hour. So those of you that can hang around past the 10 o'clock time, UK time, there'll be a 3 or 4 minute video demonstration of DNS over HTTPS. HTTPS and how we control it. So hang around for that. As ever, if you want to move to the next slide, please. We'll be running a quiz, and like to talk about one of my stress events. This is hopefully going to go smoothly today. Fingers crossed, we'll get everything right. As ever, ask questions, post your questions in the Q&A chat. If they are people you think will benefit from watching this content, please send them the invites. This is an open webinar to anybody that cares to join. I'll talk about this now. The content will be made available to you. It will be hosted upon a portal, which we are standing up at the moment. And all the recordings from the previous events, if you've registered, you will get access to. So even if some of your colleagues can't necessarily join live, they can watch back this content if they register at a later date. I will provide all the details when they become fully available. So without further ado, we will move into the content, and I will hand over to Doug to run you through URL filtering.
Thanks so much, Chris. Yeah, so welcome to the webinar today. I guess before we get started, I'll just remind everybody about the Q&A function. It should be at the bottom of your Zoom tab there. We've got a whole host of panelists who are not showing their beautiful faces today, ready and waiting to answer your questions. So if there's stuff you want to get into that's more technical than what we're going to cover, or you have specific questions, or if you've even got questions that you've thought of from the weeks that have gone past, do ask them there in the Q&A. That helps us create FAQs. It helps us communicate better about what we're trying to do. So we do really appreciate that feedback. But a little bit about me. So I'm a systems engineer here in the UK, one of Chris's team. And it's my job to sell the core platform, or explain the core platform for Palo Alto. So that includes the firewalls, Prisma Access, VM series, endpoint protection, and cloud security. But almost everything we do, we're coming back to talking about this problem. How do we stop? How do we prevent attacks from happening? And as we're talking more and more to users about how they structure the defenses, how we reshape them for the modern age with more advanced and more interesting attacks coming in from the community, it always becomes about how can we stop it sooner? How can we stop it before it begins? Whenever you look at any anatomy of any attack, one of the first defenses you're going to see is your DNS and your URL filtering. Yeah, you could say this is the short straw. This potentially is the most boring topic today. Is this not just a bunch of categories? Are we not just sorting out what is good and what is bad? Hopefully today we can change your mind on that. So let's start with the first topic here and talk about advanced URL filtering and what do we mean by this? So a filter. What we're doing ultimately is we are still sorting out what is good from what is bad. We put a lot of trust in filters every day. There's a GIF of a coffee filter here today. And if coffee grounds end up in your drink, that's not a good day. But equally, if you filter out too much, you're going to take away from the flavor. So as with all filters, it's trying to get everything in balance. We want things to be accurate, but we don't want things to be overly permissive. But the challenge we've got today now goes beyond what is good and what is bad, and into what do we trust something even if we say it is good. I'm the proud father of a 3-year-old, and I can promise you, as with any parent of a 3-year-old, I do not trust a word she says. I always verify. Do we need to go to the bathroom? Are we sure? Are we sure? It's always about what is really true and what is really going on in that moment. But how did we get to here? So let's talk a little bit about the history of URL filtering or web content security and where we think we've arrived today. So back in the 1990s, we were looking at really static on-premise filtering. The internet was fairly new, and certainly the commoditization and the access to the internet was pretty new. So we had static databases that we were putting out into places like schools and libraries, where kind of those names from the past, like NetNanny, now ForcePoint, WebSense, SurfWatch, they got their starts back in this day and age. And it was pretty simple. It was saying, reputationally, we know this is bad, and we're not going to allow people to browse to those websites. There was a need to centralize that, though, and move away from endpoint-based filtering, and instead we moved it to centralized proxies, and next-gen firewall came in around that time as well. Ultimately, we were saying there needs to be a database of bad and good, and we'll filter out the bad. But really, at this point, the industry atrophied at the web crawler stage. We were going out, we were starting to automate the classification of websites, and we were getting cleverer ways of doing that. But really, the only change that we then saw into the 2010s was where we did the filtering. Still the same underlying technology. Was we moved maybe to cloud hosted, which arguably is more efficient for certain use cases. But really, what I want to highlight here is the industry atrophied. The industry stopped innovating. We're still relying, even today, on mostly bots to go out and check the new websites as they're spinning up. And ultimately, this leads to lots of gaps. Then here in 2020, Palo Alto, we've introduced deep learning inline categorization. And we're now moving away from relying solely on bots to classify our websites. And we're now shifting into the machine learning age and letting machines do it on the fly. So why is this still important? Why do we still think URL filtering is worth investing not only an hour of your time this morning, but also a lot of time configuring and making sure we get it right? Is ultimately new malicious web pages are springing up like wildfire. And now we can write them with AI, we can write them with bots. The content that they're showing can be created automatically. It is much easier now to register something than it was even 10, 15 years ago. And what we're seeing specifically for phishing attacks, this is the initial vector. And almost all of these attacks are originating with web-focused intent. So we need to start focusing our defenses more on this first part of the attack before we get to the C2, before we get to the initial breach. We see this from our, this graph here comes from our Unit 42 incident response department in Palo Alto. These are the guys going out and fixing your bad day after it's happened. And we're seeing about a third, just over a third of the attacks are still using phishing as the initial attack vector. So they're exploiting vulnerabilities, they're putting in the phishing content that's using that URL, that's using that DNS request in the first instance. So we really need to get on top of this. Why is it still so successful, even though we've come on, we've got all these new technologies? And the reason is simply the static URL filtering database and how quickly we can get the content in there. Because ultimately it comes down to this: what is the website that we're looking at? Is it a shopping website, news website? Perhaps there's some of those more grayware categories that are more reputational based. And then we have our known bad categories, the security, the phishing, malware, C2 stuff that you always go in and block. I'm going to pause here and just shout out, go and check your categories today. Do regular reviews of these categories. Palo Alto is adding in new categories from time to time. Make sure you're going through the 70 or so and making sure they are being blocked in the way you want. Also, we have the multi-category approach in Palo Alto, so make sure high risk is being blocked, make sure ransomware is being blocked, even in still the traditional category-based approach. The amount of times we're doing best practice assessments and see there's just been mistakes or things missed, go and check your categories today. But how do these categories get informed? We have crawlers, and every vendor is doing this, including Palo Alto. They go out, they access the website, they view the content, and then they give you a category, and if the website is dumped into that location, we then update that database very frequently for you. If you look at your system log in the Palo Alto firewall, you'll see how frequently that database is updated. But if I can spin up a website almost instantly, and even a website within a known safe domain, then almost every URL could become a 0-day. The rise of things like single-click links, for sure. And that means every user on any device in your network could become your patient zero. So how do we solve this problem? We need to get around this need for the bots, the web crawlers to go out and solve the problem. Because hackers are so easily able to manipulate this weakness. And if we look at these 5 categories here, we can sum them all up quite neatly into they are human interaction dependent. They require you to click something. They require you to do something. They require you to be on a specific operating system or solve a simple puzzle. They need you to be a person. So I have seen it a lot more in my own browsing, having to click the tick box or move the slider in order to gain access to the website. And this just means the bot is not seeing the content, or they're seeing a faked version of the website rather than the true malicious version of the website. So I can say very simply, I only want this malicious website to be available to Android phones. I've immediately defeated all the web crawlers, and it's going to go into a benign category, or even more worryingly, into a safe category if I put something believable in front of that. So how do we solve this problem? We think we have the first in real-time inline URL filtering engine that's going to give you complete visibility and unmatched detection. It's going to do analysis on the websites in real time. Not just the URL, but the content of the web page will be analyzed in real time, and we'll be able to detect these malicious websites as they appear in your users' browsers. We've seen already a 40% uptick in our detection rates from the traditional web crawler-based approach on the live content, and specifically for highly evasive techniques, a 90% uptick in detection rate using ML, machine learning-based detection models. So how does this work? How are we doing this? How are we pulling this off? Well, as you've seen from Stam and Matt's presentations in the last couple of weeks, is we're using the cloud to deliver this level of compute. But we're also doing some machine learning on box as well. So we've got 2 levels of machine learning, as well as still the static database that's on the firewall. That hasn't gone away. That's always there as a fallback. But there's machine learning that ultimately happens on the firewall in line. So we're looking more at the URL, the format of the URL, any kind of strange anomalies that we're seeing there. But then we're passing that URL up in real time, and we're waiting for a verdict to come back from our cloud-delivered security services. So this is taking all of that threat data that we're seeing, whether that's from Wildfire unpacking new files, whether that's from other security subscriptions discovering something, and then additionally also looking at the content of that web page, and I'll go through an example shortly. That is then returning a verdict back to the firewall. If we think back to my example of the 3-year-old, is you're saying true or untrue? Are you actually a shopping website? Are you actually a news website? We're able to check this as the user accesses it. So I don't want to go into the details of machine learning. You can certainly go and look that up on your own. There's certainly some great resources coming out there of all these different types of machine learning that we're talking about. Lots of vendors are saying this magic buzzword at the moment. I'd encourage you to go and educate and learn how to ask us good questions about machine learning. But for this, we're really using supervised style. We're looking for something specifically. We're saying go and find things that look like phishing pages, that look like malicious websites, or code within the website itself. How does that work? How do we enable this? This really is easy. Go on and check this today. Open up your URL filtering profile and check that these 2 boxes are checked for the local inline categorization and the cloud inline categorization. That is all you need to do to access this ability to inline categorize your websites. Lots of you will have this and have not realized it. So if any of you have renewed with Palo Alto Networks in the last kind of 18 months or so, you will have been put on to advanced URL filtering from our standard URL filtering, and that will give you this capability. I would really encourage you to go and switch it on now. All it is doing is it is categorizing correctly. So it's enforcing what you've already told it to be the case. So that's another piece of homework for you already. So let's talk through an example really quickly before we hand over to Cohen, and we can talk about DNS. So this is a good use case of why this is important, or why bots are so easily fooled, or even why domains are not a good way of blocking content, is we're seeing a real rise in the host of SaaS platforms to host malicious phishing sites. So known safe SaaS platforms hosting malicious content. So let's look here. Now, hopefully everyone on this website, on this webinar, can spot immediately that this is obviously a phishing page. But we think money, money, money. This is talking about people's salaries and bonuses and potential pay. All it takes is this sort of content at the right time, and you might just get one person putting their username and password in, and that's all it takes. But it's hosted on a known site that's hosting kind of these free to create, free to host content. It's only when we look up the website and we look at the actual content of this page that we can see quite quickly that it is malicious. It's not been built properly because it's, in this case, it's missing the body text. That then gives us a whole chunk of deep learning data we can now factor into our machine learning model to say this is now malicious. Websites that look like this. Same story here on Evernote. So this is the website, evernote.com, being published publicly. So this would probably get through a lot of your filtering, or the kind of standard domain level filtering for this sort of SaaS application. Then we're also looking at what is missing here. Is there no visual form detected? There's no body text. Again, these are all suspicious indicators that we're going to see this doesn't look legitimate. That's feeding the optical character recognition and the content engine in the machine learning. If we look at the timeline here at the bottom, going from kind of 2021 up to kind of middle of last summer, we're seeing almost an 1,000% increase in this type of attack being used. So these types of safe platforms, whether it's Wix, OneDrive, Google Drive, so things that you will be allowing as part of your corporate policy for collaboration or for file hosting, being used as part of malicious attacks. Now, you add in all of the different oh, I'm just getting some feedback that the slides are low res and blurry. Is that okay for everybody? Yeah, okay. Hopefully
looks good for us. So
yeah,
keep
that's
it.
good.
And the recording will have the full res versions on there. We will share this out. So sorry about that, folks.
Good stuff. So we've got Google Drive, we've got OneDrive, they're hosting malware. So you add in all of these different security subscriptions we've been talking about. It's going to protect you from the file-based attacks, but also these web content-based attacks, the JavaScript, the body text, the HTML, the certificates, that's all being analyzed by advanced URL filtering. Is it legitimate? Is it real? So my key takeaways, the traditional approach is dead. We need machine learning to be operating at scale, to be doing this content categorization for us in line for that link at that time. There is no other way to attack this problem. We need the use of machines to fight machines. And the more and more data we feed into it by ticking those boxes, the better our models are going to become over time. But to move it on swiftly, I think, and I want to propose to you today, that you need both advanced URL filtering and DNS security. Now, Cohen's going to illustrate this, but content categorization, or like the categories that we've been talking about today, is what should impact domain reputation, not the other way around, like some of our competitors do. They mix DNS content categorization and security of DNS. What I've been talking about here today is how we can protect these content categories once they've been assigned. But Cohen's going to even push further into the theme of what we're talking about today. Before the URL is even loaded, a DNS request is made. So over to Cohen to talk about DNS.
All right.
So stop sharing. And Cohen,
thanks a lot for that, Doug. I was just going to tell you that you indeed needed to stop sharing, as opposed to what we saw in the dry run. Hi, welcome everyone. So I'm Koen, working from the BLUX part of Palo Alto Networks. Also in SC as Doug, I'm in Steven's team. What we would like to talk to you about today is DNS as such. So we just heard the very nice explanation of Doug on the advanced URL stuff. We can go one step, well, I was going to say further, but it's actually back. Looking at DNS as a protocol itself. So when you're looking at DNS, there's a few things that stand out. It's a bidirectional protocol. It's internet facing in most of the time. It has the possibility to carry data, and it is virtually impossible to turn off. So all of these things combined make it a very powerful tool for attackers, because it's running everywhere. There's also the fact that there is a huge dependency of a lot of things on DNS. If you look at, for example, how Intune from Microsoft does its stuff, it really it makes it a very powerful covert channel. There is the possibility of abuse for data theft, etc. Historically speaking, when we look a bit back, the internet was not really designed to be secure. So it was designed to move pictures of cats and stuff like that. Meaning that in the beginning, when you look at things like DNS spoofing, DNS cache poisoning, etc., it was really easy because there was no mitigation in place. After a while, basic mitigations became a thing. Again, reinventing the whole thing was impossible. So getting a very high level into the security was not possible. So we started doing things like randomizing transaction IDs, etc. After a while, we started to combine this with random source ports, creating a key that was a lot more difficult to find, but still not impossible to predict and to exploit. Aside from that, there's also the possibility of exploiting the DNS resolvers themselves, like we saw a while back with the DNS mask thing. So that brought us essentially to the place where we are today. So we are at the firewall level, including machine learning, in order to make sure that your DNS is secure. We have quite a lot of researchers at Palo Alto Networks who are very hard at work trying to understand the attack landscape and adding in new protections across a whole bunch of different scenarios. So looking at the screen, I will not go through each and every one of them. We don't have the time for that. But you can see the ones with stars, where we were the first in the industry to really decently protect against. Looking at DNS tunneling, looking at wildcard DNS, compromised DNS zones, strategically aged domains, for example, looking at the reputation of subdomains, etc. So also for once, the title is actually of importance. So we're looking at the abuse of the DNS protocol as such. So not only the protocol, but really the abuse of the protocol. So in a few slides, I'll go into DNS tunneling. We'll have a look at strategically aged domains, sorry, and we will look at compromised DNS zones and how we can protect against those, just as a matter of example. So we see that the modern network security will really require a new approach. So we see that today's attacks are mainly based around the unknown. They are very invasive, meaning that they require really deep analysis. Aside from that, we need to do this in real time in order to prevent the patient zero as much as possible. So we've reshaped the ML-powered next-gen firewall by running deep learning on live traffic, so detecting the unknown attacks. And the fact that we're in line allows us to defend the initial targets of the attack. Also important to know is that in order to do this right, we don't have the compute power on the boxes. So just as Doug said, we are looking at a cloud-based approach. This is also part of the seamless as the cloud delivered security subscriptions. One more thing to mention is that it doesn't really matter what you're using from Palo Alto Networks as part of your protection, as part of your security platform. We have the same exact approach when it's about the physical appliances on-prem, whether you're running software firewalls in your cloud environment, or if you're just doing security from our cloud delivered SASE solution. How does it work? What's the flow? So one thing that's very important to understand is that if you're looking at a DNS security solution, it needs to be very easy to implement. It needs to be consistently across the whole thing, because the volume of threats are getting really bigger each day. So what we do is we look at your DNS requests coming from your devices. we will push them through to the public DNS server, but in the meantime, we will also push the request to our cloud environment in order to do the security on top of things. We will then have the answer from the DNS server. We will have it back, but in the meantime, we also have the DNS verdict. So let's say if it's a malicious verdict, we will then manipulate the response in order to make sure that the next connection is not going out to the malicious website or to the malicious domain, but we will give you the opportunity to sinkhole this traffic. Sinkholing this traffic really means that instead of connecting back to the malicious stuff, we will connect back into a server that we set up ourselves, and I'll show you the configuration in a few slides. But this gives us a few possibilities. It gives you the possibility to, first of all, identify the infected host. And aside from that, you can also have the automated policy actions on your firewall. So there's a possibility there to restrict your internet access for that user, or to prevent really the lateral movement through the firewall. So very briefly, how does it work inside, or how does it work from a network point of view? First of all, we will look at the known malicious stuff. As soon as we see that there is a signature that is matching, we will immediately block the traffic, of course. Aside from that, if we suspect something that is to be malicious, we will send the traffic for analysis to the closest regional point of presence. Again, it's a cloud service. We will evaluate this in a matter of milliseconds. After we get the verdict back, we will check the session against a number of false positive checks. And then we will take back the result to the firewall in order to block the session that is potentially malicious. So that's in a few words how it functions. This slide provides you some quite interesting numbers, and what struck me most in this is that DNS security has really actually the highest detection rate of all of our subscriptions, and yet it's not one that is being used a lot. So it's very early in the chain, allowing you for very early detection of this. So due to the fact that we integrate it natively and not resolver based as some other people do, we have complete visibility, and the coverage is very comprehensive. So if you just look at the numbers, and I will leave this slide in for your reference, we are talking per quarter about billions of blocked domains, about tens of millions of domains that we block because of domain generated algorithms, etc. These are just numbers from one quarter, and it's only it's really only going up. And as I already explained, but again, it's not only the next-gen firewalls that have this capability, but also the Prisma Access solution, etc. So I'll now jump into a few examples and how we are actually detecting this. So talking about compromised DNS zones, for example, when attackers are using domains for attack campaigns, if they purchase a new domain, in this case malicious.com, oh sorry, that's additional. If they set up a malicious domain, there is a few disadvantages from their point of view. Then first of all, a newly registered domain, it doesn't usually have a reputation, or it has a bad reputation, so those can easily be blocked by reputation-based detection systems. Second, a lot of these domains have quite specific patterns in their names, so random characters, because they are being generated instead of just being bought. And lastly, there is a quite suspicious traffic behavior going through these domains because they're not being used as a normal domain. So that is also something that deviates. So this led to the fact that attackers have started to adopt a bit of a new strategy, which we call in this one domain shadowing. So instead of registering new domains, what they do is they compromise legitimate domains, and they create the malicious subdomains for them. Meaning, as also Doug already explained to you, this means that the existing detection systems are quite ineffective. So if you have the Apex domain that has a certain reputation, which is good, you're just going to go through in your security chain. So how do we detect it? We are going to look at, we don't have a lot of time to go in a lot of detail, but we're going to look at the relationships between IPs and host names. We will go through literally terabytes of user DNS traffic and passive DNS information in combination with the whois information that we can extract, then a couple of features from that can expose suspicious behavior of this domain shadowing thing. The fact that we are doing this powered by machine learning achieves a very, very high accuracy, so close to 100%. If you look at the detector coverage for our shadow domains and you compare it to anything that you see in VirusTotal, there's a quite big difference. And VirusTotal will only capture about 1.6% of the domains that we are detecting. Another example, maybe somewhat better known to a lot of people, is DNS tunneling. So DNS has been abused for covert communication in a lot of attacks. On one hand, there is the ability to exfiltrate data from victim hosts outside of the network by encoding certain data into the subdomains. And on the other hand, there's also the possibility to really infiltrate data into the network, as there is the possibility, as I said in the beginning, for the DNS protocol to carry data. Even worse, when you look at the more recent attacks, we've seen that attackers, they seem to have time on their hands. If you look at DNS traffic as such, the DNS packets are very small, meaning that you can either exfiltrate or infiltrate very little data at a time. But if you look at the network, all of your systems are constantly sending DNS packets. So it's a very noisy protocol, meaning that it's, for the bad guys, it's quite easy to hide in this noise and to transfer the data very slowly. Also meaning that it's quite difficult to distinguish these type of queries by hand. If you look at, for example, the more sophisticated attackers, they have multiple domains under their control, and they have the ability to exfiltrate data towards different domains at once. This is even slower, so we've called this ultra slow DNS tunneling, but also it's also something that we see happening more and more often, and making it even more difficult to detect. So how do we detect this? Is we are looking at a whole bunch of characteristics of DNS tunneling. So we see that benign domains usually have meaningful words in their subdomains, because you need to go to them as a human being. Where DNS tunneling rarely has meaningful words, it's more a bunch of characters, etc. We see that the number of queries for domains is quite different in benign traffic compared to malicious traffic. We are looking at the entropy of the domain names. We're looking at the length of the domain names. We are looking at the ratio from the different query types, like the A records and the NS records, etc. So what we do is we build profiles for the benign domains, and then we are identifying the deviations from that. So again, this is a bit the overview slide of what I just explained. So both of our detectors, exfiltration and infiltration, are really designed to conduct a real-time analysis of the DNS traffic, and we aim to block this infiltration and exfiltration in a very short time frame. So we are looking at patterns, we are looking at semantics of things. We are looking at the DNS responses as well. So the name servers and DNS records should be valid. So if we see stuff going on that cannot be resolved, usually it's also a bit fishy already. In your threat logs, you will see that we will also show you quite a lot of information. The information that we show you is essentially to make sure that the teams that need to be that need to do the incident response can do it more effectively. So we are going to show you inside of the threat logs the different tunneling tools that are being used, the threat actors, if we are aware of them, the impact that it has on customers, etc., etc. So even the malware campaign name will be shown in our threat logs. One last example that I have for you is strategically aged domains. So what is a strategically aged domain? It's a domain that has been registered in advance and that has been left dormant for months or even years before the attack campaign. So especially operating APTs, there's a bunch of there's a good idea behind it. So the longer life of an aged domain can help to evade the reputation-based detection systems, as we already mentioned, and it's much harder to really detect in this way. So we see that there's about 30,000 domains on each and every day that have been dormant for months or years that gain a whole bunch of traffic within one day. That's quite suspicious. So looking at, for example, what we saw in the Pegasus spyware campaign, if you look at the graph, you will see that the amount of traffic suddenly exploded at a very certain point in time. So there were multiple domains that were registered already in 2019, and only in July 2021, the DNS traffic exploded by a factor of 56 in this one. Another example is a very well-known attack, was the SolarWinds attack, the supply chain attack, where also the strategically aged domains were not only used to gain the initial access, but also to for the C2 afterwards and the data exploitation that was done. So we look at a number of identifiable patterns to really detect and to prevent these things. So what we are going to do, we are going to look at the subdomain DGAs. We are going to look at the traffic pattern classifiers itself, and of course we are running machine learning on this. So again, we are using our threat intelligence that we have from thousands of customers around the world. We will look at passive DNS traffic and at the user DNS traffic as such. Once again, coming from either the next-gen firewall hardware or from our Prisma Access solution. For your reference now, I've added some screenshots, and as Chris already said, the presentation will be shared in order to show you guys how to enable the DNS security. I will show you, after the presentation here, I will show you a short movie that also demonstrates how to set it up. So again, the sinkholing thing is in a little box here. It really enables you to identify the infected hosts, and it'll allow you to automatically take action on your policy in the firewalling. So this is the anti-spyware where it's configured. You literally put this tick in the box and you put your sinkholing in place and everything is good to go. One last question is, what about DOH and DOT? Because that's also been a hot topic for the last few weeks and months. When you look at the encrypted DNS traffic, we see a difference on either DOH, which is DNS over HTTPS using port 443, and DOT, which is DNS over TLS using port 853. So important to notice here is that since SpanOS 11, the most recent version, we also support DOH. DOT has been supported already for a bit longer. So before this version, before this release, our recommendation was to block it because your clients will fall back in case they can't do it. But since SpanOS 11, we give you the option to also decrypt this traffic. In order to set it up, more for your reference, you are going to create your URL profile with the acceptable resolvers. And we are going to block, or we'll ask you to block any other resolvers to drop the DOH traffic. And after this, you actually configure your DNS security in the anti-spyware profile as you would do in the other ones. The logs are similar to your regular DNS logs that you see in the threads, as I already showed you. And again, a small reminder for those who have the time, we will show you a short video at the end that shows you how to set it up. And we'll show you how to do it. That is my cue to go back to Chris.
All right, brilliant. Look, thank you, Koen. Thank you, Doug, for a cool presentation. So look, to summarize, we've got multiple tools that will prevent a lot of breaches before they happen. URL filtering, we can block the high risk categories, just prevent access. But we can get earlier in the attack life cycle than that by preventing, bad DNS requests and looking at DNS as a protocol and to protect it. I guess a key takeaway is architecture matters, right? The only way we can do this is through cloud delivered services with machine learning and AI. And with that, we are uniquely positioned with our architecture to scale these services out to protect thousands and thousands of customers at scale. So with that, obviously, there's the call to action, which is, you can try it. If you're a customer and you have our firewalls, you can try any of our CDSS cloud delivered security services subscriptions I've got the links or the QR codes to the specific URL filtering and DNS security subscriptions as well. Scan those, by all means, enable those subscriptions on your firewall. If you want to move to the next slide, please. If you are not a customer, we can do security lifecycle reviews. We can place firewalls in your environment, and we can mirror traffic, and we can show you what's going on. Obviously, if we're in line, we can decrypt, which gives you better visibility, but we still give you good visibility as to what's happening in your environment. And that can help you make some informed decisions about how you can modify your current cybersecurity posture. For those who want to learn more, we've got the Beacon Learning Portal, where we have all of our content available to you for free. You can go register with your work email address and access that content and read and review. This is a topic we've barely skimmed the surface of today. There is a huge amount of detail, particularly in the DNS. So as Kuhn showed, there were 30 odd different protections that we deliver. When we publish the slides, I recommend you go look up each of those different types of vectors, so you can understand the granularity of the protections that the DNS security provides, because it's vast. So moving on to the next slide is the survey. As always, your feedback is a gift. We appreciate it always. If you want to complete the survey, if you want to speak to anybody in sales or indeed in systems engineering, if you want more of a technical perspective, by all means request it. Please don't fill the survey in as anonymous, because we cannot contact you. We don't know who you are. So there's a few people that have submitted surveys in previous weeks where they've filled it in as anonymous. If you've not been contacted by us, that is probably the reason why. So if you can leave your email address in the feedback, we can make sure we get back to you. And obviously, if you want to talk more broadly about things that we do, not just the topics that you've heard from here today, then please let us know. Also, I'm shaping the next Back to the Future series. It may not be called Back to the Future, but we'll see. We're shaping it now. So if there's any topics you want to deeper dive into, please let us know and we can build that content for you. All right, next week. So Matt Smith is coming back. He's making a second cameo appearance to talk about AI Ops. So AI Ops brings a lot of things together. Firstly, there's DNS dashboard, so we can look at the reports of how DNS is protecting your environment, but also, Doug and Cohn both touched on this about configuration. How do you ensure everything's configured correctly? And within AI Ops, we give you the tools to do this, and the recommendations to build policy around where you deviate from best practice. So it's a constant best practice kind of tooling. There's a lot more in there, but Matt will talk about that. I don't want to steal his thunder. But it's far more about being proactive than reactive when we come to managing our, firstly, security posture, but also the technology estate that we have deployed. So that's next week. So onwards to the quiz winners. So I love this bit to reveal the winners, because we highlight some of the places where the quiz went wrong last week. But this week was reasonably clean. So we had some clear winners, which is good. So Cohen, if you want to reveal number 3, please, who came third? Sarah Main, congratulations to you. You were third fastest with the correct answers. We will be in touch. Number 2, who came second? Jeremy Doling, congratulations to you, Jeremy. Cracking result for you as well. And then finally, and this is where it went a bit wrong, number 1, who came first? Lucas. So Lucas, if you could contact us with your surname, we can find out who you are, because there are quite a few Lucases that join the call. So Lucas, we won't be in touch unless we can find out who you are, but the Sarah and Jeremy, we will be in touch. But congratulations to all our winners. Stellar performance, getting all the questions correct. So you were clearly paying attention. Okay, then onwards. So winners in previous weeks, we are slowly getting around to contacting you. You will receive an email that looks like this. And as I say every week, if you are not a winner and you receive an email like this, then it's probably phishing. If you are a winner and you receive an email like this, then go claim your gift. Superb. All right, so we will move on to this week's quiz, which remarkably we're running ahead of time. So Cohen, if you want to just pop the next slide up, and I will load up the presentation.
I'll probably have to stop my sharing then.
Stop the share, please. Yeah.
Yeah.
Okay, I'll just load up this share screen. Menti.com. Okay, right team, please register for the quiz. We'll give us a couple of minutes for the QR up. We got 23 in already. That's good. That meant I got step 1 correct, which is putting the right slide in the right place. So only 23. Do we have a problem? Rid. Okay, I will mention actually before we get into this quiz, Palo people, please do not participate. You will be excluded from the results. We've still not got many people joining the quiz. Do we have a problem with the quiz? If people have,
I just tried myself as a matter of test, Chris, and I'm not getting. I just see instructions, but nothing else. So I do think that there is an issue with it.
Interesting. Okay, let me stop the share and let's go restart the browser. We had a problem with like this on week 1, so talk amongst yourselves just for a second. Oh, browser seems to be freezing. My browser has frozen. Stefania, could you do me a favor? Could you share the quiz, please?
Yes. One second.
My browser is frozen completely. This is what happened in week 1. It's the quiz. It's due never to go slow, to smoothly. It's always causing a problem.
But can you stop sharing the presentation?
No, I cannot do anything. Okay.
Okay.
Let me mute the tab and see if that helps. Does that help?
No. Oh, done. I can share my screen now.
All right. Love live demos and quizzes. What could possibly go wrong?
Right. It's like people.
Fantastic. We love a plan B. All right. Cool. We're at 89. We will see if that settles down around that mark, and then we will progress. Stefania, will you move the slides for me, please, when I give you the nod?
Yes.
Just give it a little minute more because we're still getting more people joining. I think whilst I'm in the office, I might give this laptop to IT and understand why it keeps freezing. Okay, 98. Are we going to make 100? This will be 100 people on the quiz. This is a first. Fantastic. So yeah, before I forget, if you could please join with first name and last name, so we can actually hunt down who you are and we can give you the prizes. It's much easier for us in the back end. I don't know if Lucas has made contact today or whether he's on the call, but if you could put your name.
He's reached out.
Excellent. Thank goodness we didn't get them all reaching out. All right, we're steady at 103. Okay, let's start the quiz. Stefania, please. Epic. All right, same rules. Fastest finger first. So the faster you answer correctly, then more points. So let's go to the first question, please, Stefania. Oh. Okay. There we go. Does DNS security require a resolver? True or false? Yes or no? Fast responses there. People coming in quickly with that one. All right, here we go. No, it does not. Our DNS security does not require a resolver. Because we're in the path of traffic, we see most DNS requests anyway. Therefore, we can analyze the DNS requests in real time. We do not need to be a resolver. Superb. Let's see how the leaderboard goes. Stefania, next slide, please. Jeremy Doling looks to be at the top. Oh, Leon and Leonard, well done. Great result from you guys. Okay, next question, please, Stefania. Question 2. Is using a defined DNS service secure, e.g. trip quad A? Yes, no, but App ID would solve it, and no. All right, correct. 48 of you were correct. No, it is not secure. All right, let's look at the leaderboard. Leon, fastest finger on that one, and Ian McLaren making an appearance. So Ian taking top spot. So on average, you've done the best. And Matt Beckett, good to see you in here again. Leon coming third. Okay, next question, please. How is DNS security enabled on our next-gen firewalls? I should say it's not just next-gen firewalls. It's also in SASE and VMs.
It's called something different in SASE, so we had to be specific.
Fair enough. Fair enough. Part of anti-spyware, correct. 26 of you paying attention to that one.
Yeah, so in SASE, it's part of the DNS security profile, so hence why we had to be a little specific on this one.
Bit of a trick question there, Doug. Cool, but we were talking specifically about firewall. You are correct. All right. Ian McLaren, good result. Leon as well, still up there. And Geert making an appearance on that one. I think that's how you spell your name. Let's say your name. Excellent. All right, moving on. Question 4. Okay. Answer fast to get more points. What percentage of attacks use phishing for initial access? Did anybody pick this up in the slide? Well, some of you did. That was fast for a lot of you. Okay, 5 more seconds. Oh, 37%. It's lower than you think, but it's still a lot. It's still a lot. So I don't know if you want to talk about where those numbers came from.
So that was part of the Unit 42 investigation, so incident response services. These are our guys going out and cleaning up. So from there, annual report that we release. So you can go and Google that annual report on the state of ransomware, state of the nation. You can see these graphs and more of them. Really helpful for writing investment business cases.
100%. So Unit 42 published lots of wicked content, lots of great content around the state of attacks, like the landscape, but also they published something called Atoms, and that shows you how we break down campaigns and the protections you can deploy using our technology against it. So that was it. So next question, was that 4 or 5? Lost track. So busy talking. Right, Ian McLaren, Andy Deeks, Geert, and Ian McLaren making up the top 3. So it's getting tight at the top. There's not a lot between you 3. Okay, where are we at? Question 5. Fantastic. Last question. We won't show the leaderboard after this one. What is the key difference between traditional URL filtering versus the Palo Alto approach? Well, this has got you thinking. All right, correct. It is real-time compromise assessment. So we are looking at traffic in real time and making real-time categorization decisions and protecting you early in the attack lifecycle. So absolutely, 51 of you correct on that one. And with that, we are done with the quiz. We will not be showing the leaderboard. We will announce the winners next week. So for those of you that can stay on, Cohen, I don't know if you want to share your screen and run through the demo, given that my browser is frozen.
I will try. I had a very similar issue just now.
Okay. I have restarted in the background, so we can see if we can make it work.
Are you going to share, Chris, or?
Let me try.
Okay.
Okay. This is just a short video showing
It is.
how we do DOH configuration. So you should now see a video. Fingers crossed this will play. Unable. So it's typical. So there's something very, very wrong with what's going on in my machine.
Let me try that again, Chris, for you.
There we go. Cohen, are you sharing sound as well?
I was just about to ask that same question. There's probably an option somewhere to share the audio as well. Share computer sound. Okay, let's try that again.
In this DOH demo, we will look at the configuration needed on the firewall, see how to generate DOH traffic, and look how to monitor the DOH-based threat logs. All major browsers support DOH. Most OSs like Windows, Mac, and Linux have support for DOH. Open source DNS servers like Bind, Outbound, and ADDNS also support DOH on their DNS server. So there is a good chance that users on the network would have enabled DOH on their setup. So it is important to monitor DOH traffic and provide visibility into it. Let's look at the DOH configuration. The first step is to create a custom URL category with an allow list of acceptable DOH resolvers from your environment. You will need to identify and add all the host names associated with these DOH resolvers. In terms of policy, we first have to decrypt HTTPS traffic to understand the DNS payload within it, then create a decryption policy with the custom URL filtering profile. The next step is to create a DOH allow security policy. You will allow and apply DNS profile to all the traffic with app ID, DNS over HTTPS going to sanctioned DOH resolvers defined as part of the custom URL filtering profile. One thing to remember is that since DOH traffic is going over HTTPS, you will also need to create an explicit block all rule for all other DOH traffic. You will select applications as DNS over HTTPS and URL filtering category called encrypted DNS. This is a category that we added as part of the DOH workflow where we continuously monitor for the DOH resolvers and add that as part of our database. If you see any unknown DOH resolvers, we will add that. You can use that to improve your security posture. Let us generate some DOH traffic. We will go to the client machine and open a Chrome browser. In Chrome, by default, DOH is disabled. So we will go to the browser security setting and enable secure DNS. Choose DOH server URL from the drop-down list or add a custom URL. Here we are using the Quad 9 DOH server URL. That is all that is needed to generate encrypted DNS traffic. With this, the name resolution request will be encrypted. Let us test with some light traffic. Benign sites like CNN would be allowed through, but bad sites would be blocked. As DOH traffic goes through our firewall, we decrypt it, apply a DNS profile, inspect for any threat, and block it. Now let's check the threat logs on the next generation firewall. Here you can see malicious DOH traffic getting logged. You would see that traffic goes to the rule DOH approved that we created. There is a DNS threat ID, category, detection type listed. So basically, we display all the details of DOH traffic as we would do for regular DNS traffic. If you go through the detailed log, you can see the applications as DNS over HTTPS. This helps distinguish regular DNS traffic where the application would be DNS based from DOH traffic. This concludes the demo.
All right, fantastic. Look, we got there in the end. So with that, we can wrap. But thank you, Doug and Cohen, for putting your presentations together. Thank you, everybody, for joining this call. We appreciate you spending your time with us. We know your time is precious and valuable. I hope you found it useful. As always, fill in the survey. If you had some feedback, some commentary that you would like to give us, we are all ears, because your feedback is a gift. Join us next week for Matt Smith talking about AI ops and how we start to bring a lot of this together in terms of management and best practices, and how we can help you be more proactive around your security posture. But with that, thank you and goodbye.